Welcome to the C2 Space Chronicles, where we share the messy, iterative, definitely experimental process of studying human physiology in extreme environments. Today's video is about studies. Some particular choice studies that I looked at and I think informed our design, either because of the way they were limited or interesting data that may be helpful in our trek to figure out effect size and eventually run a power test. So here are a couple of studies that I thought were worth sharing with you. First, there was this paper by Mura et al. It's a 2016 paper. The title is Effect Size for the Main Cognitive Function Determinants in a Large Cross-Sectional Study. And I really like this study because it covers 11,711 volunteers, 45 to 75 years old. And it was an overarching, really solid look at how age, gender, health, education, smoking, et cetera, affect DSST results. So come on, that's like was made for me. Thank you so much. What I found most interesting about this study is the fact that there was statistically significant evidence that the DSST scores went down with age. And they went down pretty linearly and quite predictively. And I just can't do anything much with that information at this point, but it gives me a sense of the fact that, there seems to be quite a range in DSST performance that is attributable to age alone. And that reinforces our idea that we are going to have to compare people to themselves and not to each other, because DSST varies so much based on age. And this study and other studies will also confirm based on gender. So that's something that we're going to stick to. It also means that we need to get enough data for every individual, because every individual will only be compared to themselves. So here's a study that I thought was actually very relevant to what we're doing, and we're definitely going to be incorporating it later. And this is Kenneth et al. It's a study called Relationship Between Alertness, Performance, and Body Temperature in Humans. Definitely body temperature is relevant when we're talking about diving. It's cold. Colder usually. And I just thought this is a really good way to have a different baseline. And it was for sure really informative for us to keep discussing the idea of effect size. The study consisted of 14 healthy adults, unfortunately only 3 women, 11 men, 11 men. And the mean age was 31.6, with the range being from 20 to 41 years old. The DSST was given to the individuals at varying temperatures to test their working memory and cognitive throughput. And the results were interesting because it showed that there is, in fact, an impact of temperature, of body temperature, on your DSST performance. And that's relevant because if we're looking at a certain number of point variation that is simply attributable to temperature, then when we are looking at cognitive function, we have to take into consideration that temperature is a confounding factor in DSST results specifically. And not surprisingly, the conclusion was that as body temperature increases, working memory improved. And then they did other tests, including the PVT, which we are going to use as well underwater. And so this is actually very informative. What I did not see, which was frustrating, was an effect size or an explanation of their power analysis. One of the studies I looked at was Hoyer et al., which is called Adult Age and Digit Symbol Substitution Performance, a Meta-Analysis. The study reconfirmed that the DSST is a robust marker for describing sample characteristics in studies of age difference. And that is definitely something that we saw in the first study we talked about, the 11,000 French people. And again, we see that there is a decrease in DSST performance that is entirely attributable to age. You will see in these results here that the triangles indicate the younger adults, the circles indicate the older adults, the solid lines indicate the regression line for younger adults, the broken line indicates the regression line for older adults. and they using the DSST. But again, you will see that there's a variance of about 25 points on average that is attributable to age alone. So again, I was getting increasingly frustrated because I'm not seeing a clean, easy line, which means that we are going to come up with an effect size that we care about based on the amalgamation of all of this data. And that's what's going to happen. And that we are going to have to look at individual variance, because that's going to become a pretty big driver. If individual variance is 10 points around the mean, then if we are seeing people doing even statistically significantly worse underwater, but they're within that 10-point variance for each individual, I don't think we're seeing cognitive impairment as measured by the DSST. Maybe other types of cognitive impairment, and that's something I talked about at length in my first video, but not in that particular area. Another study that I think is going to be very relevant, because it's going to give indication of the real life importance or significance of the results we're going to find, is this one. It's Dong et al. From March 2020. It's the association of coffee, decaffeinated coffee, and caffeine intake from coffee with cognitive performance in older adults. It was a National Health and Nutrition Examination survey. What I liked about this study is that there was a very large group of participants, 2,513. The slight drawback is that the population is 60 years or older, which means that it's not entirely relevant to the population that we're going to look at. Some people, but not all divers. So that limits a little bit its applicability. What I liked seeing, though, because it reassured me, it was this last sentence here. Currently, there is no gold standard of cutoff point for the SARAD, animal fluency, and DSST test to identify low cognitive performance. So we are really not looking at something we're not going to find an answer that says, oh, they're showing low cognitive performance. We are really going to be looking at whether they are individually impaired, which is why we're going to have to look at their own baseline. And then I did like seeing this, and now you know what we're looking at as well. You can see there that in the fully adjusted model, there was a significant association between coffee consumption and DSST score, and you see that there is a very small beta score, which means that there is a very high likelihood that you are not committing a type 2 error. So it was nice. I got to see that. I thought, oh, somebody's giving me a bit of an answer. So that was exciting. What was perhaps most interesting was the nonlinear relationship. So apparently there was a marked decrease in the DSST score, and then an increase. So apparently if you dose with enough coffee, then you might be doing better. There was a drawback to this study, which is kind of obvious, is that if you look on the bottom, it says coffee intake grams per day. That's not caffeine. That's literal how much coffee you are drinking. And as you know, the concentration of caffeine can change very markedly from one coffee to the other. And so I would say that's a serious drawback. So these results don't really tell me a whole lot, because unless I know how much caffeine they're actually ingesting, I have no idea what this means at all. Another study that I had the chance to look at was a 2016 study by Rosano et al., digit symbol substitution test in future clinical and subclinical disorders of cognition, mobility, and mood in older adults. Here, the DSST was again administered, and they used it both as a continuous and a 4-level categorical variable based on quartiles. And I thought, oh, that might be interesting. That might be an interesting way to look at whether people are scoring in their own lower, middle, upper middle, higher quartile, depending on depth. And I thought that might be something to implement if we are still struggling with the concept of power and effect size. And importantly, if we end up finding that the sample size we need is just too big to obtain from practical purposes. And I know it sucks to hear that, but that's the reality of what happens in science. That sometimes the sample size is just too big and the study can't do that. And so there's ways that you work around it. And I'd rather we not do that. I'd rather be transparent about what's going on, which is one of the reasons I'm making these videos. And that concludes this episode of the C2 Space Chronicles. Thank you for watching, and I'll see you next time.